All right, AP Calculus related rates problems. Here's the airplanes problem. An air traffic controller spots two planes at the same altitude converging on a point as they fly at right angles to each other. One plane is 150 miles from the point at moving at 450 miles per hour. The other plane is 200 miles away from the point and moving at 600 miles per hour. So the question we have to answer here is, at what rate is the distance between the planes decreasing? Well, first thing I'm going to do is draw this little picture. And I think what I'm going to do is I'm definitely going to call this x of t, but I'm also going to say that I have an airplane that's right here and he's flying in this direction. And x of t right this second is 150 miles, isn't it? 150 miles and flying at and this is negative 450, right? The other airplane is 200 miles, so I'm going to say this is my other airplane right here. Y of t equals 200, and the rate is negative 600. So I'm just going to start writing down some stuff that I know. One thing that I know is that dy dt, the rate at which the plane is moving this way, given time, is negative 600 miles per hour. Dx dt, because they gave it to us, dx dt is equal to negative 400, because it's converging on this point, right? So what I want to do from here is try to piece this thing together. What we want to know is, we have distance here. So what we're looking for is this. How is this distance? Here's the one airplane, here's the other one. They're getting closer and closer to this point where they're going to collide. They're going to collide at this point. What's this distance? C to start with, and then we want to know, we need dc dt, assuming that we're going to call this value c. So first thing I'm going to do is I'm going to put my triangle together. And I know that one leg of my triangle is 150, so we get 150 squared plus 200 squared is equal to c squared. I don't know if you can see this or not, but this is a 3, 4, 5 triangle. If not, you can just do this math. But I'm going to skip to it and tell you that c is equal to 250. So it's equal to 250. So 250 here. The next thing I'm going to do is go back to this. All of these things are changing on us. So I'm going to have to differentiate this whole thing. So what I'm going to do is say this. I'm going to say that c squared is equal to x squared plus y squared. Or if you want to keep it in terms of what we have, x of t plus y of t squared and squared. And this is c of t squared. So what I'm going to do is I'm going to differentiate with respect to this, because this is what I want. So I'm going to get 2c dc dt. Here I'm using I'm using the chain rule, right? I'm taking the derivative of the outside, which is 2c. The derivative of the inside is dc dt, isn't it? If this is throwing you off, you can always use this. You can always use this. You can leave out that t if that's throwing you off. So I'm just using this because it's in regard to time. So I'm going to differentiate this, which is 2x dx dt plus 2y dy dt. It seems like, oh my gosh, what's happening here? But we're doing fine. And the reason that we're doing fine is because we know all these values. We know all of these values. One thing that we could do here is we could divide all this by 2. If we divided the whole thing by 2, these 2's would go away, wouldn't they? If we just divided this by 2. From here, believe it or not, all I'm going to do is divide all of this by c. So I'm going to take dc dt is equal to 1 over c times x times dx dt plus y dy dt. And I'm sure that this is looking to you like, oh my God, what's going on? But we're in great shape because we're almost done. We have all this information. All we're going to do now is just fill in the blanks. So I'm going to say dc dt is equal to, well, we know that c is equal to, right, the value of c is equal to 250. So 1 over 250 times, and if we're going to fill in all this math here, x is equal to 150. X is 150, right? dx dt, we got that early on, was negative 400, so negative 400 is like negative 450, right? Negative 450. Sorry, I didn't read that correctly. Negative 450 plus, we know that y is equal to 200, and we know dy dt is negative 600. And if we do all that math using our calculator, we're going to get out that this plane is moving at 375. The distance is changing at 375 miles per hour. And that's our answer. That was not that bad. The second part of the question kind of goes on a little bit. And it says, how much time does the air traffic controller have to get one of these planes on the ground? Well, the plane's going 375 miles per hour, where t is time in hours, right? And it has to go 250 miles. So we can just do this math, and we'll get t is equal to 250 over 375, which is about equal to 40 minutes. So they have 40 minutes to do something about this before these two planes collide. All right, so I hope this was really helpful to you. These problems are not simple, but they're very, very doable. If you haven't already subscribed, please do. If you have questions, please let me know. Thanks. Got to keep doing the math, you guys.